Let's start with the next topic, converting decimal to octal number. Now previously we have seen the conversion of decimal to binary, where we have divided the decimal number by 2. Now here we'll be dividing the same way, the same procedure is followed here, but the division will be by 8 and not by 2, since we have to convert the decimal to octal number. The procedure to obtain the decimal to octal number is called method of successive division by 8. That is, here we keep on dividing the number by 8 and we keep the track of the remainder. The division by 8 is continued till we obtain a zero coefficient. Once the zero coefficient is obtained, we stop the division and we keep the track the same way we have done for the binary number systems. Let's take the example 177 to the base 10. This number is a decimal number. We have to divide this number by 8 to obtain the octal equivalent. So the first 177, we divide by 8, we get the remainder 22. We get the coefficient is 22 and the remainder is 1. We keep the track of this 1. Since it is a non-zero coefficient, we continue the division unless we get the coefficient as 0. After the division of 22 by 8, we get the coefficient as 2 and the remainder is 6. Now this 2 is again divided by 8, and after this we get the coefficient as 0 and the remainder as 2. That is, 8 zeros are 0 and the remainder is 2. Now we have got here the coefficient as 0, hence the division is stopped here. So we keep the track of this LSB and we write the equivalent octal number of 177 in the way we move from bottom to top. That is, this 2 is written as MSB, 6 is written as the middle number, and 1 is written as the LSB. That is, we proceed from bottom to top. The same is written here, that the answer is written from bottom to top. The same is in the binary case. Okay, let's move on to the conversion of the next is from decimal to hexadecimal number. The procedure is the same what we have followed for decimal to octal number and decimal to binary number, but the only difference is that here will not divide by 2 or 8. The number or the decimal number will be divided by 16. Okay, again it is the same as the integer division, but the number is divided by 16 and we keep the track of remainder the same way we have kept in the previous two methods. The division is continued till we get the coefficient as 0, and the coefficient and the remainder so obtained after obtaining the 0 coefficient is taken as the MSB, the same way we have done for binary and octal numbers. Let's take an example to understand the conversion of the number systems. This 4768 to the base 10. It is a decimal number. We divide this by 16. So after this division we get the coefficient as 298. Since the coefficient is 298, the remainder is 0. That is, this coefficient is not a 0 coefficient. Hence we continue the division and we keep on dividing till we get the 0 coefficient. That is, the previous coefficient was 298, so we divide it by 16 and we get it as 8, which is a coefficient, and the remainder is 10. Now the difference is here. It is a very important difference to be noticed. Here, as we know that the number 10 in hex is represented by A, the number 11 by B, 12 by C, and so on, the last number F by 15. Therefore this 10 will not be written 10, instead this 10 will be replaced by A. Similarly, though we proceed further, 18 by 6, the remainder is 2 and the coefficient is 1. Now the last step is 1 divided by 16. We get the coefficient as 0 and the remainder is 1. Since the coefficient is 0, we don't need to proceed. We can take the hexadecimal equivalent from bottom to top in the same way for the previous three cases. This 1 be MSB. Okay, this 2 is the rightmost bit, then A, and then 0. That is, we read the answer from bottom to top. Now the next way or the next step is converting binary to decimal numbers. Okay, this is again a very simple procedure to obtain the binary number into a decimal number. The only difference or the important trick here in this topic is that we multiply each binary number with the power of 2. That is, here it's a 0th bit, therefore 1 into 2 raised to 0. This is the first bit, this is the second, third, fourth, fifth, sixth and seventh. So this LSB is the 0th bit, that is 1 into 2 raised to 0 plus 1 into 2 raised to 1 plus 0 into 2 raised to 2 plus 1 into 2 raised to 3 plus 1 into 2 raised to 4 plus 0 into 2 raised to 5 plus 0 into 2 raised to 6 and plus 1 into 2 raised to 7. After the addition of these numbers, we get the decimal equivalent. So we'll take a valid example to have a brief idea about this conversion of the number system. Let's take the example of 1001. This one is the LSB, that is the 0th bit, this is the first bit, this is the second bit and this is the third bit. Please note, we always move from right to left while counting the position. That is, the rightmost bit or the LSB is the 0th bit, first bit, second bit and third bit. So the calculation is 1 into 2 raised to 0, that is 1, plus 0 into 2 raised to 0 plus 0 into 2 raised to 1 plus 1 into 2 raised to 3. That is 1 into 8 plus 1 into 1. It gives the decimal equivalent as 9. Similarly, this example, the 0th bit, the green one is the 0th bit, the first bit, the second bit and the third bit. That is 1 into 2 raised to 0 plus 1 into 2 raised to 1 plus 1 into 2 raised to 2 plus 0 into 2 raised to 3. So the addition of this bit gives 7. Similarly is this example. I'll have some rough idea about this example as the procedure is same for these two numbers. This is the 0th bit, first bit, second bit, third bit, fourth and fifth. Therefore 0 into 2 raised to 0. Since the addition is 0, here it is not mentioned here. It is considered as 0 by default. Okay. Plus 1 into 2 raised to 1 plus 1 into 2 raised to 2 plus 0 into 2 raised to 3 plus 1 into 2 raised to 4 plus 1 into 2 raised to 5. Therefore the addition gives 54. The next step is converting binary to hexadecimal. The conversion between binary and hex is the same way, but the only difference is that the binary numbers, that is 1010, the first step is they are divided into pairs and they are divided into groups and each group are having 4 bits. Conversion between binary and hex is done by substituting 4-bit group for hex digit of the same value. This is a special type of thing unlike other form of conversion. So the example for this is this example. Let's say we move from right to left, that is, this is the LSB and this one is the MSB. Okay, so what we'll do is here we will first divide these bits into groups and each group will have 4 bits. That is, first group will consist from 1 1 1 0, which is taken here. You can see 1 1 1 0. Okay, this is the first group. Now discard this bit and take the second groups. The second group will be having bits as this one 1 1 0 0. See, 1 1 0 0. Okay, moving on further from this one 1 0 0 1, same way, and the last group will be 0 0 0 1. So after the division is done, that is after we have groups with each group having 4 bits, we now take its decimal equivalent. Sorry, we now take its decimal equivalents. The decimal equivalents will be obtained by multiplying it by 1 into 2 raised to 0 plus 1 into 2 raised to 1 plus 1 into 2 raised to 2 plus 0 into 2 raised to 3. This addition, it gives the addition as 7. Similarly, this bit 1 1 0 0, this one, the LSB one, we multiply this by 1 into 2 raised to 0 plus 1 into 2 raised to 1 plus 0 into 2 raised to 2 plus 0 into 2 raised to 3. So the addition of this bit is equivalent to 3. Similarly, for this bit is 9, and for this bit, this group 0 0 0 1, this group is having its decimal equivalent as 8. Therefore, the hex equivalent of this number is 8937.